So welcome to problem set number 5, which will deal with the topic of tax inefficiencies and their implications for optimal taxation. So today's exercises will be quite similar or related to the exercise that we had 2 weeks ago. So last week we had a holiday day, so there was no exercise. But 2 weeks ago, we talked a little bit about economic incidents and of taxes and the statutory incidents. And this week, we will talk about related topics. So let's start with exercise number 1. The market demand for super sticky glue is 240 minus 6p, and the market supply is minus 40 plus 2 times p. P here is the price and Q is the quantity, as usual. In sub-exercise A, we're asked to calculate the deadweight loss of a $4 per unit levied on the producers of super sticky glue. Okay. So last exercise session, we had one way to calculate the deadweight loss, and that we calculated the consumer surplus, then calculated the producer surplus, added up everything to get the welfare, the total welfare in the economy, and then we compared the two welfares before and after taxes, and by this we basically calculated the deadweight loss. But there is another shorter way which we can use, which is that the deadweight loss is equal to the following. So it's equal to 1/2 times the tax, so the tax per unit, times the change. So write this in parentheses. Change in quantity due to the tax. Okay, so this is a very simple formula which you can use to calculate the deadweight loss, and which we'll be using now for this exercise. So there are two things we need to find out, or one thing we already know. We know that the taxes here, that's equal to 6. So that's, it's equal to 4. And now all we need to find out is the change in quantity due to the tax. So quantity in equilibrium, of course. So let's calculate this. So let's find out the quantity without the tax. So without tax, we have the following situation. Without tax, the demand is given by 240 minus 6 times P. This should be equal to the supply, which is minus 40 plus 2 times P. And now if we solve this equation for P, we get that P star, so the equilibrium price, is equal to 35. And now if we enter this equilibrium price in either the supply or the demand function, let's do it with the demand function. So Q star is equal to 240 minus 6 times P star. And now if we enter the equilibrium price, we end up with a quantity which is equal to 30. Yeah, so this is basically the equilibrium quantity without tax. And now with tax, what we have is a change in the supply function, in that the supplier has to kind of transfer $4 per unit sold to the government. Yeah, but keep in mind that this doesn't mean that the supplier is actually bearing the economic incidence of this tax. So there is no change with respect to the demand function here. So this stays the same, but now it should be equal to minus 40 plus 2 times P minus 4. Okay, so for each unit sold, the suppliers need to transfer 4 units to the government. And if we solve this, we end up with P star equal to, if I'm not mistaken, should be 36. And now if we plug this into either the demand or supply function, we end up with the new equilibrium quantity, which is then 240 minus 6 times 36. This is equal to 24. Therefore, the change in quantity is then simply 30 minus 24, and this is equal to 6. Okay, and this was the remaining unknown, which we didn't have up here. So then this here is equal to 6. And then if we calculate, the deadweight loss, it's then 1/2 times 4 times 6, and this is 24. Therefore, the deadweight loss, it's 12, of course. It's 12. We have to divide by 2. So the deadweight loss due to tax of $4 per unit levied on the producers of super sticky glue is equal to 12. Yeah, so $12 is what we lose due to this tax. So in sub-exercise B, we're asked whether the deadweight loss change, or if it's we ask whether it changes, and if it changes, what is the change in the deadweight loss if the tax is levied on consumers rather than the producers. Yeah. So if the statutory incidence is carried by consumers rather than producers. So since we know the difference between a statutory incidence and an economic incidence, we already know the answer to this question, in that it shouldn't change, or it doesn't change the deadweight loss. So there is no change in deadweight loss. I will shortcut deadweight loss with DWL. And the reason is simply the economic incidence of the tax does not depend on the statutory incidence. Okay, so the change in the deadweight loss is due to a change in behavior of the individuals. Yeah? And the change in the behavior of the individuals depends, or is characterized by the elasticities. And that's all that we need to calculate the deadweight loss. So just because some other party has to actually transfer the money to the government, it doesn't mean that the incentives are changed. So the elasticities change. Yeah? And that's the reason why the deadweight loss will not change, but we can calculate this. So let's do it. So the situation with the tax is as before. So now let's consider a situation where we have the tax, but now it's on the demand side. So the demand function now is, so with tax on consumers, what we have is the demand function changing to 240 minus, minus 6 times P plus 4. So now for each unit that the consumers are buying, they have to pay $4 to the government. So that's the reason why we have a change in the demand function here. There is no change with respect to the supply function. So it's minus 4t plus 2 times P. And if we solve this, we get an equilibrium price equal to 32. And the quantity, Q star, is then equal to, we can either use the demand or supply function. Let's use the supply function this time. So 4t plus 2 times P star, and that's equal to 24. And that's exactly what we had in sub exercise A. So there we also had 24 as the quantity with the tax. So now the dead weight loss again. So dead weight loss is 1/2 times the tax, which is still $4, times the change in quantity. So before the tax we had 32, now we have 24. So that's then, let's write it down explicitly, 32 minus 24, and then this is equal to 12. So there is no change in the dead weight loss due to a change in the statutory incidence. Okay, this brings us to exercise 2, where we have a table given. So you're a consultant to the government of Bethany or Botany. The government has decided to cut taxes on one of the following: apples, bananas, or cantaloupes. The government wants your input on which food would be the best choice for a tax cut. It provides you with the following information. What is your recommendation and why? So basically, here we are asked to look at the 3 different goods which are given and to basically compare only this part of the table. Like all the rest is quite irrelevant for the question which is asked here. So we only need to focus on this, because this part of the table tells us exactly what is changing due to a change in $1 of tax. Yeah. So if we increase the tax by $1, what do we lose in terms of taxes or gain in terms of taxes if we decrease taxes? And what's the dead weight loss, the marginal dead weight loss that we suffer from for each $1 unit of tax that we impose on the good? And that's all that we need to compare. And in general, and this is something that we will see, I think, in exercise number, let me just check. It's exercise number 5. Oh no, sorry, it's exercise number 6. So exercise number 6, we will derive a situation where, which will be more kind of precise than what we do in this exercise, because here, what you have probably also seen in the lecture, or you will see on Monday, I'm not sure, is that if you want to have efficient taxes, they should be in a way that the marginal dead weight burden per marginal dollar of revenue generated is equal across the goods. Okay, so let's write this down. So exercise 2. Taxes should be set such that the marginal dead weight burden the marginal dead weight burden per marginal dollar of revenue generated is equal across goods. Because if this wouldn't be the case, then you could reset taxes in a way such that you could have an increase in marginal revenue, and like you could have an kind of an increase in marginal revenue for one good, which has kind of, sorry, you could have a decrease in the marginal revenue, which would induce a loss in marginal dead weight, which is lower compared to the other goods. Yeah, so we basically trying to find a good for which we have the least efficiency or the least deadweight loss if we increase the taxes. So that's the idea here. Or on the other hand, if we cut taxes, it's also the same idea. Yeah. So how should we kind of reduce taxes such that we get the most revenue generated with the least kind of efficiency lost due to a marginal deadweight loss. And what we will do now is we will compare basically those ratios for the three goods that we have here. So we will basically have the calculate the marginal deadweight burden per marginal dollar of revenue for each of the goods. So let's calculate this. So marginal deadweight burden per marginal dollar of revenue. So let's do it for for the goods that we have. Apples. For apples, it's 5 divided by 20, which is equal to, I think it's 0.4. Then we have bananas. Which is 20 divided by 30. Let me just get my calculator real quick so I get the exact number. So it's 2/3. So it should be 0.6. 0.6. I think that's the correct. Let me just check to be sure. Yes. And then we have cantaloupes. So here we have 20 divided by 10, which is then equal to 2. Therefore, as we can see, first of all, it's not the same everywhere, so the ratio is not the same. And we see that for cantaloupes, this ratio is the highest. Yeah, so basically, the answer then would be that we should cut taxes on cantaloupes for efficiency measures rather than for any other of the goods. Yeah, because it's the most efficient way to cut taxes, to generate revenue with kind of least deadweight loss. So cutting taxes on cantaloupes would be most efficient. because for a given revenue reduction, cutting cantaloupe taxes reduce the deadweight loss the most. Yes, so if we cut taxes, so we decrease taxes, we lose tax revenue. But the idea here is that the gain in the overall gain due to a reduction in the deadweight loss is also highest when reducing the taxes on cantaloupes. And this is basically the reason why we should then reduce the taxes on cantaloupes, because, okay, we lose some revenue, but the gain that we get because the deadweight loss is reduced is highest here. And if you compare the ratios, you will see that it makes sense to reduce taxes on cantaloupes rather than the taxes of any other goods. Okay, this brings us to exercise number 3. So suppose that in the country of Tributia, a worker's supply of labor is given by 140 times W, and a firm's demand for labor is given by 2000 minus 20 times W, where W is wage per hour, H is quantity of hours worked. The government of Tributia decides to impose an income tax. Calculate the deadweight loss that would be expected if the government imposes a proportional tax of 25% on all of the workers' earning. Okay, so this will be a little bit similar to exercise number 1. So we need to calculate the equilibrium wage per hour and the equilibrium quantity of hours in equilibrium with tax and without tax, and then we do the comparison again to calculate the deadweight loss. So without tax, we simply set again demand equal to supply. So 140 times W should be equal to 2000 minus 20 times W. And if we solve this, we end up with W star being equal to $12.5. So I will not write the dollars here, so you know it's a monetary value. And then if we plug in in either the supply or demand function, let's do it with the demand function, we get the equilibrium hours worked, which is then 140 times 12, or let me just write it down like this so you know what I'm doing. So 140 times W star. And if you calculate this, this is equal to 1,750. Now with tax, there will be a change in the demand side, because now workers, for each unit of quantity that is of work that they supply, they do not receive W, but they receive 0.75 W, because there is a reduction of their earning due to this proportional tax of 25%. So the effective wage is now 0.75 times W. Okay, so that's what the suppliers are getting So yeah, sorry, I mixed up before when I said that I'm plugging in the equilibrium wages into the demand function. This was wrong. This is the supply side of the market. So it's always confusing in labor when you talk about labor, because the consumers who work in a goods market are actually the suppliers of labor in the labor market. So that's a little bit confusing. Yeah. So yeah, the supply side is receiving a wage of 0.75 times W. That's the effective wage. So now what we calculate is the new equilibrium wage, which will be then simply getting by setting equal the new supply function to the demand function. So 140 times 0.75 times W. This should be equal to the demand side, which didn't change. So the demand side here is our firms. So it's 2000 minus 20 times W. And if you calculate this, you get W star equal to 16. And if you plug this into, for instance, the supply side, you get H star equal to 140 times 0.75 times 16. And this gives you 1,680. And the wage that the worker receives after taxes is now $12. Yeah, so it's $16 times, so it's 0.75 times W star, so it's equal to 12. And now we can calculate the deadweight loss. So the deadweight loss, I will shortcut it again with DWL, is then 1/2 times the change in hours worked due to the tax. So it's 1/2 times 1,750, which was the quantity of hours supplied or demanded before the tax, minus 1,680. So this is the situation after the tax, times kind of the tax in monetary units that the government is receiving. So here it's 16 minus 12, so $16 minus $12. Let me just erase this little thing here. Oops, this was too much. So 16 kind of is the wage in equilibrium with the tax, and $12 is basically what the suppliers or the workers are then getting. So the government is receiving $4 for each unit of labor which is supplied. Therefore, $4 will be kind of the tax which is imposed in absolute terms. And if we calculate this, we end up with a deadweight loss equal to $140. So if a kind of proportional tax of 25% is imposed on workers' earnings, the deadweight loss in this economy will be $140.